All right, so here is the second day of 4.6, the splitting the middle term. Again, if you have a shortcut that works, feel free to use it. But if you're struggling with factoring, this method will always work if what we are trying to factor is a trinomial and factorable. All right, so first step, I multiplied my ax squared times my c value. And so now, sorry, I miswrote, and got 3z squared. So now I need factors of 3z squared that are going to add up to 4z, and that would be 3z and z. Now the order that I split my middle term up doesn't matter. I'll demonstrate in this case. Since I could have written it the other way, now in either case, I'm going to pair the first two terms and the last two terms. I'm going to factor out what I can from my first two terms. I'm going to factor out what I can from my last two terms. And if I'm on the right track, my groups will match. I factor out that matching group, and that leaves me with the values left. So notice by rewriting the order, all it does is produce the opposite matching group. So 16, I multiply my first term times my last term. Now I need factors of negative 5v squared that are going to add up to 4v. So the factors would be positive 5v, negative v. I add them together to get 4v. Again, it doesn't matter which order I write them in. I pair my first two terms, I pair my last two terms. We always want our first term to be positive, so notice I factored out a negative 1 from the second group, factored out a 5v from the first group, factor out the matching group, write what's left over. (17). Since the leading term is just negative 1s squared, I'm going to factor out the negative 1 because it's going to let me use the shortcut. Now that I've factored out negative 1, all I need to do is find the factors of negative 8 that add up to negative 2, and I'm able to factor using the shortcut from last week. Don't forget, though, to include that negative that we factored out at the beginning. Same thing's going to happen in 18, where I can factor out a negative 1 from every term. And now that my lead coefficient is just 1x squared, I can use the shortcut. So negative 3 times 7 is negative 21, but negative 3 plus 7 is 4, and so I've got my final answer. 19, very similar again to what we had talked about the other day. Leading term is 1, but notice we've got the y squared. So I know my binomials have to start x and x. The last term has to be y and y. And now I just need factors of negative 30 that add up to negative 1. You'll notice I wrote my signs wrong. Negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. And so I've got my values. Similar thing is going to happen in 20, where I've got q squared. So I know I'm going to need q and q at the end of each group. My leading coefficient is just 1, so I'm able to use my shortcut. Negative 4 times 6 is negative 24, but negative 4 plus 6 is positive 2, and I've got my values. Now, conveniently, or inconveniently I should say, we're going to notice that the values we would need to add up to negative 8 from negative 12 would lead to a positive 12, negative 6 times negative 2. No combination of factors for negative 12 add up to negative 8, so this function is relatively prime. Similar to number 22, the book is trying to confuse you and think that you can use negative 5 and negative 3, because negative 5 plus negative 3 would add up to negative 8, but negative 5 times negative 3 would be 15, so we know that this is relatively prime. 23, our lead coefficient isn't 1, so I need to use the longer method. I multiply my first term times my last term, I get negative 6t squared. So I need to figure out what adds to be 5t but multiplies to be negative 6t squared, and that would be positive 6t and negative t. I set up my new function, splitting my middle term. I factor by grouping the first two terms and the last two terms. I can take a 2t out of the first two terms, a negative 1 out of the last two terms, so I factor out my matching group and write what is left over. Again, if you rewrote it with your middle term split differently, it wouldn't change your final answer. It just means that what you factored out and what your matching group looked like would be slightly different. Notice my matching group is now 2t minus 1, and I'm left with t plus 3, the exact same answer from before. 24, again, my lead coefficient is not 1, so I multiply my first term times my last term, get 15x squared. I need factors of that add up to -8, so -5x and -3x. I split my middle term, group my first two pieces, my last two pieces, factor out from my first group, I can factor out an x. I can factor out a -1 from my second group. My matching group is 3x minus 5. So I factor out 3x minus 5, write the remaining pieces, and I have factored my trinomial. All right, last homework problem of the semester. So multiply my first term times my last term, get -18p squared. Factors of -18 that add up to -7 are -9 and +2. I set up my new polynomial. I factor what I can out of the first group, what I can out of the second group. P minus 3 matches P minus 3, so I factor P minus 3 out. I'm left with 3P plus 2. I've got my final answer. All right, hopefully this has helped. Again, this part of 4.6 is not going to be on our quiz on Wednesday. If you have any questions, please ask in class.